So why do we have to worry about limitations of inverse trig functions? Well, I had a graph. I had decimal calculator graph x in terms of the sine of y. What I'm getting is something that's obviously not a function because it fails the vertical line test. So I've got to find another way to deal with this, and this is what we decided to do. We know that the smallest value a sine can take is -1, and the largest is +1. So that's the x's. That's why that blue graph stops at the x, and then the y values, that's the range. Well, that's positive pi over 2, and that's negative pi over 2. So that's why the range is anywhere for arc sine is between negative pi over 2 and positive pi over 2. You'll only get answers from your calculator in that range. If you've got something that's in quadrant 3 and quadrant 4, then you got to think about what you're doing, think about reference angles and all that. But that's what the calculator tells us. Okay? And that same note, for cosine, we're limited. We know the largest value cosine can take is 1, and the smallest it'll take is -1 again. And here's where that cosine graph is. So that means our range for the cosine is 0, and that's pi. Notice a little bit more than 3 on our graph. Okay, so we're using the inverse cosine function on a calculator. We're only going to get answers between 0 and pi. If we're thinking about something between an angle between, in quadrant 3 or quadrant 4, then we get to deal with reference angles and reference triangles and think about it that way. So this is out of section 6.3 on page 386. This is number 19. So they're asking us to evaluate this composite trig function. So, well, I started off with the inside, and I drew an angle of pi over 4 degrees, or pi over 4 radians, sorry. And then I thought about the reference angle, and I decided that this is the cosine, and this is the sine, right? X and then y. So I know the cosine of pi over 4 is root 2 over 2. And now I'm going to drop that into the arcsine function of root 2 over 2. Well, thinking about the domain or the range limitations on the arcsine, I know I'm only going to be in those two quadrants there, in quadrant 3 and 4, or 1 and 4. So down here, if it's an angle, a reference angle of pi over 4, it's negative. The sine is negative root 2 over 2, whereas up here is positive root 2 over 2, and that's what we're looking for. We're looking for the arcsine of root 2 over 2. Well, the only place that's true is right here in this quadrant, so it just so happens that in this situation the answer is the same as it was, root pi over 4. So for number 21, we need to decide on evaluate this. So what I've done is I've thought about the inside function, which is the cosine. So there's the graph of, or there's an angular rotation of 4 pi over 3 radians. I know the reference angle's pi over 3, which tells me that's a 60-degree angle, which if that's 60, that makes this side the root 3 over 2, makes this side the 1/2. And down in quadrant 3 here, both x and y are negative, so I know that's the values. And I know x is the cosine, y is the sine. So that's that answer. And they're asking me to find the cosine. So the cosine should be, the number we should be looking at is -1/2. Okay, and if you look, I also decided to insert a copy of the unit circle. If we see, there's the 4 pi over 3, and notice those are the same coordinates of the points that I had. Okay, so we're looking at, we want to find the arcsine of -1/2. Well, remembering what I was just talking about, how when we're dealing with the arcsine function, we're only going to get answers between positive pi over 2 and negative pi over 2. So we got to remember this graph, as this shows the angles from 0 to 360 or 0 to 2 pi. So we're going to have to be thinking about how that is the same thing as negative 30 degrees or negative pi over 6. That's negative 45 or negative pi over 4. and that's going to be negative pi over 3, right? So we're looking for, where's the sign negative 1/2? Well, let's see. Right there, I'm seeing a sign. Remember, sine is y. So there's where sine's negative 1/2. So that'll be that as a reference angle of pi over 6. So that tells me that answer should be negative pi over 6. Okay, and we're within our range of negative pi over 2 to positive pi over 2. Okay. Now this problem isn't quite so slick because we know that 3 over 7 isn't one of the nice 30, 60 right triangle numbers or isosceles triangle, right isosceles triangle. So we got to do a little bit of do some thinking here. We're asked to find the arc sine of root 3 over 7. So I'm not root 3, 3 over 7. So I know sine is opposite over hypotenuse. So I know this is 3, this is 7. And this will have to be, using the Pythagorean theorem, 49 minus 9, and we're going to take the square root, so the square root of 40, which we probably might want to write as, let's see, this is 4 times 10, and we're taking the square root of each of those, so 2 square roots of 10. Okay, now that we're supposed to find, here's the angle, so now we're asked to find, now this is the angle, right? I don't know what the angle is, I really don't care, because I know that the arc sine of root 3 over 7 will be that whatever that angle measure is. But now what I'm going to do is I'm going to find the cosine of that angle. So I don't really even need to know what the angle measure is. I just got to remember that cosine is adjacent over hypotenuse. Here's my adjacent side. Here's my hypotenuse. So 2 root 10 over 7 would be the best way to write that. Same kind of deal. We're looking for what angle has a tangent of 4 over 1. Well, let's see. So here's a triangle. Opposite is 4, adjacent 1. And here's our angle, which we don't know what it is. And then the hypotenuse is going to be 1 squared plus 4 squared, and take the square root. So what's that? Square root of 17. So now they asked us to find what's the cosine of this angle. Well, cosine's adjacent over hypotenuse, so 1 over the square root of 17. And if we've rationalized this, we're going to multiply by root 17 over root 17. So root 17 over 17 would be the answer to that question. Now we're getting to things that are a little more elaborate. So what we're looking for is we want to find some angle that has a cosine that's x over 5. Well, let's draw a triangle. We know that the adjacent side is x, the hypotenuse is 5. This side over here will be 25 because it's 5 squared minus x squared, and then we're going to take the square root. Now they're asking us to find the sine of that angle. So the sine of that angle will be opposite over hypotenuse. So 25 minus x squared square root over 5. That should be the sine of it. You'll have to do this in calculus when you're trying to do derivatives of inverse trig functions. It's towards the middle, second half of that course. Okay. So the same kind of deal. We're looking for some angle that has a tangent that's equal to 3x over 1. So let's draw a triangle again. We know the opposite side is 3x. We know the adjacent side is 1. So the hypotenuse will be 1 squared plus 9x squared, right? Remember, we get to square that whole thing for the Pythagorean theorem. So now they're asking us to find the sine of that angle. Here's the angle. So the sine's the opposite, which is 3x, over the hypotenuse, which is 1 plus 9x squared. And fortunately, since this is an expression, they aren't going to make us rationalize that.